Good evening, we enthusiasts. This is your pilot speaking, and we have already sailed through rough weathers last week where we encountered the clouds of derivatives. The flight was going all pleasant, but we have encountered another dangerous looking cloud, and that's called integration. So we have to pass through this thunderstorm very safely. Do not worry, I have your back. So we are going to sail through this storm of integration very safely if you just follow my advice like before. So remember one thing, those who can bend the wind will also weather the storm. Read it again. Those who can bend with the wind will also weather with the storm. Interesting, isn't it? Welcome guys, this is Shreyas here, your master teacher for physics at Vedantu. And I'm going live from the Bangalore studios on this very own channel of yours. From all your love and support, we Enthuse. Welcome aboard. So I was just reading all the chats before I join in over here. So if you are wondering what I do before 7 o'clock, I in fact keep reading all your chats on the screen out here. Yes, so there is a chat screen for me. So I keep reading all your chats, and it's so nice to see all your chats, how you interact with each other and how the bond is becoming slowly stronger. And a lot of regulars out here. Yes, welcome Revan, Sonu, Nidhi, Muskan, Kirito, Rishabh, Gamer, Chini, Ankit. Welcome Khushi, welcome Uncharted, Biswajit. Welcome Papi, welcome aboard, welcome Deepak. So somebody was asking, sir, what about the JEE advanced problems? So let me remind you, in my previous session where we all three of us interacted with you, we clearly told you that we are going to slowly scale it up. Please keep in mind there are all kinds of students. There are some students who have just started preparing or maybe they have prepared till some level, maybe board level, and now they want to scale it up. Some students have obviously probably done with their coaching material and now they want to scale up the level more. So do not worry, just be patient. We are going to get there soon. We are going to come to advanced problems also. Now the first target in front of us is JEE Mains. So let's concentrate on JEE Mains, and then slowly we are going to go to the JEE Advanced also. And if you have been seeing the drill questions, there are very good questions in the drill assignments as well. Okay. Thank you guys. Thank you for all your love. I can see all the hearts, the fire, the love, the smileys. Yes. So Rishabh, dot and cross product will be taught to you as an application in work and talk. Okay. So also let me tell you why today's session was cancelled, because the studio is being set up at Wasim Sir's place and Shimon Sir's place, and they are back to their hometown, so on their way, and it is going to take some time for the studio to be set up. So that's the reason why the lecture today was cancelled. So I hope you understand that they were on their way back, so that was the reason. All right, so tomorrow I believe you will be having chemistry and maths and physics as usual. Okay, so we are going to aim to complete most of the parts, and you can see when our syllabus will be completed, etc. In my previous video, all three of us have spoken about what is our action plan for JEE 2021. So please go ahead and check how to score 200 plus marks in JEE examination 2021. All right, all your answers are there. All right, yes, do not worry Ankit, even if you are in 2022, you are going to write it the same way as these people are, just 1 year difference. So portion is safe. Do not worry, we are going to come up with 12 standard exclusive batch or series as well after JEE Mains is over. But yes, whatever we are doing now is also useful for 11th standard, all those students in 11th who are going to give KVPY, etc. Okay, yes, do not worry 2022 students, we are there for you as well. So right now just concentrate on the 11th standard syllabus. Okay, so having said that, let me tell you what we are going to do today. Today we are going to do integration in kinematics. We have already done derivatives. In case you have missed that class, please go ahead and in the playlist you can find all the lectures, all the sessions which we have conducted. Just go and look at derivatives also, right? That is also very important for this class. And this whole week is all about dynamics, Newton's laws, friction and all that. Okay, so today we are going to do integration. Tomorrow in the morning you will get the video discussion, yes, the solutions of today's assignment, which will be provided in the description link below as well as in the Telegram group. So do not forget to check that out after the session is over. And in case you are new, do not forget to subscribe, because or else you will not get notified about the new sessions which are going to be conducted. And also do not forget to like, because then YouTube will be less likely to show you the videos which are more relevant to you if you do not like this. And also do not forget to share this with your friends, because we have to share the joy. That's what we intend to do. Yes, so Sai Reddy, maybe the internet on your end is slow, but otherwise I think the video should be fine. Yes, the flash drills are the assignments. Yeah, so those are the assignments which you get after most of the sessions, and we discuss those assignments the next day. That's what it is. Yes, Navami, this is for dropper also, right? I hope you have seen the video where we all of us have spoken about what is the action plan for JEE 2021. So please go ahead. So guys, I have spoken about all these things. You need to check the motivation, the idea, the aim, or action plan videos which you have already spoken about previously. So just please go ahead and check it out. All right. Okay, great. Okay, Saurabh, I'll look into it. Thank you for mentioning that. Yes, flash extract, I think you'll be getting it today. Most likely you'll be getting it today in the description link or on Telegram. One of them. Yes, you'll be getting it today. Do not worry. Okay. I hope that answers all your questions. So yes, with high Josh, shall we proceed for integration? Yeah, let's proceed. It will come, Satvik. Be patient. Satvik, I think you're very impatient. Just be chill a little bit. Yeah, it will come. Everything will come by the end of the session. Don't worry. Okay, chalo. Let's get going and let's see what integration is all about. Like I have been telling you, you should be conversant what derivatives is. Only then you will understand what integration is. Because remember, you're going to need all the formulas what you studied in derivatives in slightly different way, in actually reverse way in this integration. So stay tuned. Now see, let me tell you, we are going to solve many problems today, also see many formulas, and you are going to definitely get a different view of integration from today's session. So stay tuned. Now, think about this. Imagine you have a function. It could be any function, maybe sine x, maybe ln of x, or maybe x raised to n or something. If you take the derivative, you get some another function. Like, for example, the derivative of sine of x is cos of x. Derivative of x cube is 3x square. It's a different function. The reverse process, which is going from the derivative to the original function, is called as integration. That's a one-liner, simple way of explaining what integration is. So if you know derivatives, you all also know what integration is. It's exactly the reverse way. Yes, do not believe me? Do not worry. I'm going to show you some examples. Now, everybody has to play this game with me. So I have some few set of questions. So come on, guys, let's play this game. So the derivative of which quantity or which function gives you 2x? Think about it. Whose derivative gives you 2x? Just think about it. Think about it. VSG has already answered. Pramesh, Navmi, very good. Yes, Karan, very good, Giri. Correct. So x square's derivative is 2x. We all know that. So the integration of 2x is x square. So integration is another way of asking whose derivative is 2x. That's all integration is. Okay, get that in your head. So integration of 2x is nothing but x square. That's exactly what it is. Let's try this out once more. Whose derivative is sine x? Come on, try this out. Whose derivative is sine x? Come on. Whose derivative is sine x? Come on. Pranav, it's not x square by 2. Be careful. It's just x square. That 2 will get cancelled out. Okay. Yes. Not cos x, guys. Minus cos x. Be careful. Because cos x's derivative is minus sine x. But minus cos x's derivative is minus of minus sine x, which will become plus sine x. So understand, the integration of sine x is not cos x, it's minus cos x. because minus cos derivative is sine. Understand that? Yes, a lot of people get this wrong, but if it was cos x over here, well, then you can think what it should be. Yes, then it would be sine x. Okay, I hope you guys are getting it. Slowly, let's do one more. Whose derivative is 5t raised to 4? Come on, think about it. Yes, Akhil, that's it. That's the spirit. Come on, you also keep up the energy. So, whose derivative is 5t raised to 4? Come on, guys, think about it. Yes, very good, very good. Study Max, Uncharted. Yes, yes, yes. Pratham, Sonu, Navmi, Anu, very good. Amrita, Pranav, Nidhi, Preecha, very good. Yes, it is t raised to 5, guys. T raised to 5. T raised to 5's derivative is 5t raised to 4. So, integration of 5t raised to 4 is t raised to 5. As simple as that. Wow, amazing. You guys are just rocking, huh? I'm really amazed. So, you will be like, oh, is integration done? Oh, well, wait for it. It's not over yet. There's a lot of things, trust me, and we're going to solve a lot of problems, but you get the idea what integration is. So do not worry, we're going to see all those things: definite, indefinite, how to calculate acceleration, how to calculate velocity from acceleration, and all those things. Do not worry, we are getting there. So there is more. Now, here is the problem. Yes, some of you already pointed it out, like Srivats. So Priya, I'll finish the chapter today. Yeah, the integration will be finished today. What is the derivative of t raised to 5 plus 2, guys? Think about it. What is the derivative? Akhil, just join in, don't worry. What is the derivative of t raised to 5 plus 2? Come on, guys. Yes, it's just 5t raised to 4. Yes, it's 5t raised to 4. Very good. Now, because 2 is a constant, 2 just goes away. So, that's it, 5t raised to 4. Great. Now, think about this. What is the derivative of t raised to 5 plus 7? T raised to 5 plus 7. I think you guys are getting what I'm trying to tell you. T raised to 5 plus 7. What's the derivative? It's again 5t raised to 4. Well. Ankit, this is 11th standard only. Yeah. Okay. Now I think you're getting what I'm trying to say. Did you understand what I'm trying to say? Or did you read between the lines? Okay. So Shushruth, 7's derivative is 0, right? So t raised to 5's derivative is nx raised to n minus 1. So that's it. So my point is, anything t raised to 5 plus c, anything that constant, let it be anything, it's always 5t raised to 4. So that means we have been missing out on a term before this when we discussed few of the questions. Because if the original function had some constant, when I took the derivative, that constant disappeared. So when I went the reverse way, I cannot be sure what that constant was, but it could be some constant. Yes, there could be some constant. So in the reverse process, understand there is always one constant that we put because we are not sure what that original function was unless something else is given to us. If it's not given, then you need to put that constant. I hope you guys are getting it. Amazing, amazing. Yes, yes, science. Yes, Hari Kumar. Yes, Akhila, Neha, Aryant. Very good. I hope you guys are getting it now. So now let's try this out. What's the integration of 2 raised to x? 2x. My bad. So what's the integration of 2x? Think about it. So you just need to think whose derivative is 2x. Whose derivative is 2x? Yes. So it's x square, but do not forget there can be always a constant. So the correct answer is x square plus c. Understand that. So because constant's derivative is always 0. So that 0 is always there. Remember that. Alright. So that's the answer for that. Then what's the integration of x raised to 5? Interesting. What's the integration of x raised to 5? So you have to think the reverse way. X raised to 5. Whose derivative is x raised to 5? So that way you will get what's the integration. So this is reverse process is integration. Remember that. Think about it, guys. Well, first of all, remember when you take derivatives, the power reduces, right? The power reduces. So it should have been x raised to 6 and one constant will also be there. Yeah, one constant will also be there. But think about it, x raised to 6's derivative will be 6x raised to 5. Oh, but this extra 6 is there, but that 6 is not there over here. I want to get rid of that. The only way I can do it by dividing it by 6. So, x raised to 6 by 6. Very good. Very good, Satvik, Saurabh, Arihant. Arihant, I think you missed one number. You put 5, not 6. Yes. No problem, no problem. VSG, I know it's difficult, but you get the idea. Okay, very good. So that's the answer for this question. I hope you guys, how can we find the value? Yes, we can find the value. It will be given in the question. How? For example, it will be given at this value of x, this is the value of the integration. So maybe this is the value of the integration. Let's say the value of the integration is 1 at x is equal to 0. That is given, the value of integration. So from this information, you can find the value of c. Oh, looking at this, okay, constant is 1. So hence the value of the actual integration will be x raised to 6 divided by 6 plus 1. That's how you can find it out. So that will be given to you. You don't have to worry about it. All right. Okay, Rahul, join in. Yes. Yes, Ankit, this will be definitely useful for all of you. All right. Okay. So now, how do you exactly write it? Because every time you can't keep saying, right, that, oh, what is the integration of x raised to 5? Oh, it's the antiderivative of, a function whose derivative is x raised to 5. You can't keep saying that. How do you put it in words? So what is the symbol of writing that? So, for example, x raised to 5's integration is x raised to 6 by 6 plus c. So how do we write it? So here is the symbol, guys. Pay attention carefully. So, understand. I'll write x raised to 5. The symbol for integration is this. That's the symbol. And put dx over here is equal to x raised to 6 by 6 plus c. This is the integration. Now, let me tell you what each term means. This is the function whose derivative is this. Understand that. So if you take the derivative, you get this. So when I say what is the integration of x raised to 5 dx, you have to think whose derivative is x raised to 5. So that is this function. All right. Okay. So what is this dx? Remember, in derivative, you always had this d of, let's say, x cube by dx. So it was derivative of x cube with respect to dx. Remember that, with respect to. So same way, it is integration with respect to that x. Understand? So integration with respect to x means it's this function when differentiated with respect to x gives me this back. Okay, so that's all. It's always going to be there, that dx, dy, dr, ds, dt, something will be there. So that's what you will see. And obviously this is nothing but your symbol of integration. And this obviously is nothing but your constant of integration. So this is how integration looks like. Rahul, yes, please don't spam. Thank you, Pranav. Very good, very good. Rahul, don't spam. Yeah. I'm reading all of it. I'll respond whenever I feel, or I'll intervene whenever I feel it is important. Yes. Okay. I hope you guys are understanding this. Very good. Very good. Very good. Now, don't worry. Don't worry, Revant. Don't worry, VSG. It's going to be a physics class soon. And do not forget, maths is the language of physics. All right. Okay. So now, remember, this is the function which is being integrated. Dx is with respect to what you're integrating. This is the symbol of integration. That's the antiderivative of that function, or the reverse of derivative. So this guy's derivative is this, and that is the constant of integration. So this is one important slide. It talks about what each symbol stands for, in case you're wondering. So very good. Thank you, Darshan. Thank you, Aryant. Okay. Now let's start some problems. Let's think about it. All right. So guys, think what will be the integration of x cube dx. Just think about it. What will be the integration of x cube dx? Come on, guys. Okay, Aryan, join in. Come on, keep answering. Don't let the josh die out. Very good. So it will be x raised to 4, but x raised to 4's derivative, think about it, will have an extra 4 when you take the derivative. So divided by 4. And do not forget the constant of integration. Very good. Think about, what about 1 by x square dx? 1 by x square dx. Okay, now what to do for this? Don't worry, I'll now give you a general formula from which you will be able to do any kind of problem. So guys, the general formula goes like this: integral x raised to n dx. Recollect, in derivatives the power is to come out, get multiplied, and the power of x reduced in derivatives. In integration, exactly reverse. So the power of x will increase, and instead of multiplying, you will divide with n plus 1. You can see that how this works. So this is the formula in general when you have x raised to n. Remember that. All right, very good. Now some of you have already talked about what is the integration of x square dx. So guys, think about it, because x square is below. First bring it on the top. Look, make it look like this. How will you make it look like this? So it will become x raised to minus 2 dx. Very good. I hope you guys are getting it, and some of you have already got it. And see that? So here n is nothing but minus 2. So just put it out here. So it will be x raised to minus 2 plus 1 divided by minus 2 plus 1 plus c. So what will it be? This will be x raised to minus 1, and this will be minus 1. So x raised to minus 1 by minus 1 plus c. If you want, you can further simplify it and write it as minus 1 by x plus c. So that's the final answer for 1 by x square. I hope you guys are getting it slowly. Very good. I can see all of you are getting it slowly. Very good. So let's do one more problem. Integration of, let's do this. Integration of, what is integration of cos x? Think about it. What is the integration of cos x, guys? Think about it. What is the integration of cos x? Yes, Karan, integration will be taught in deep. Right now we are just going to apply it. Very good. Is it going to be just sin x or minus sin x plus c? Obviously. Is it going to be minus sin x or just plus sin x? It's just going to be plus sin x. Think why, guys? Think why? Because derivative of sine is plus cos. Derivative. So it's exactly opposite. Exactly opposite. Just think about it. All right. Very good. Yes. Excellent. Many of you have got it. So now let me give you the formulas. X raised to n. Formula is x raised to n plus 1 by n plus 1 plus c. Integration of sine is minus cos. Try to compare it. See, how do you remember formulas, guys? I'm teaching you the trick, so pay attention. Derivative of sine was cos. Integration of sine is minus cos. That's how you remember. Then, what is derivative of cos? Derivative of cos was minus sine. It's exactly opposite here. Integration of cos is plus sine. That's how you remember. Okay, but for tan and other things, it's slightly different. So integration of tan is log of mod of cos of x. This is not needed so much right now. So don't worry, I just given it. There are more formulas. I can fill up the board, but I don't think you will be needing it so much right away. All right. So we'll come to that. It's just a matter of detail where we write down all the formulas and that's it. But you should understand what integration is. And lastly, obviously, 1 by x integration is ln x. ln stands for log to the base e. Understand? Yeah, log to the base e, in case you have not yet studied logarithms completely. So you might find it a little bit difficult, but I'm pretty sure Shimon sir took one lecture on logarithms just recently, so you will be able to get it. Okay. Yes, these are at least very important, Darshan. Yes. Yes, for now, Mr. Best, you need to know the formulas. In maths, you will have to study it in detail. Yes, you will be seeing a lot of theorems, properties of integration and all that. Okay. Okay. Krito, don't worry. Once I start coming to the applications, that's when you will understand. Don't worry. You will understand when to use derivatives and when to use integration. I'm going to give you one line at the end of the session, and that's it. That is going to help you out when to use integration and when to use derivatives. So wait for that line in the end. Okay. So Gopal, the derivations will be done in maths. This is not a maths class. I hope you understand. Okay. So definite integration. Let's talk about this. Now, imagine we integrated so many things. Okay. Integration of sine x is minus cos. What if I put some value of x, another value of x, and then I subtracted both of them? So what is that called? Well, that is in fact called as definite integration, where you put two different values of x and then subtract both of them and you get a quantity which is very useful, and that is what is applied in physics. So let me tell you what it is. Remember, the antiderivative is nothing but another word or phrase for integration. So if something is the derivative of the other thing, then the integration of something will be the other thing. I'll tell you what I mean. Observe. Velocity was dx by dt, correct? Velocity was dx by dt. Velocity was the derivative of position with respect to time. Exactly opposite. X will be integration of velocity with respect to time. That's all. This is exactly opposite. And this works every time. Yes, every time. So say for example, you have this thing, acceleration is derivative of velocity with respect to time. Exactly opposite. Velocity will be integration of acceleration with respect to time. It works every single time. All right? Okay. Later on, those of you are probably in 12th or in droppers batch, and maybe you have completed Newton's laws back in your school, you would also have studied the force is dp by dt. Correct me if I'm wrong. Rate of change of momentum. P is momentum. So dp by dt is rate of change of momentum. Reverse it and it will become P is integration of force with respect to time. That's it. It always works. All right? It always works. So remember, if you know this thing is the derivative of the other thing, so integrating this thing will give you back the first one. So if you know this simple fact, guys, trust me, it's going to be simple. Yes, yes. You can also apply it in many places, like power is rate of change of rate of doing work and all that. So you can integrate work and you can get you can integrate power and you can get work and stuff like that. So it works every time. Don't worry. Okay, great, great, very good. So coming back to my point, if x can be found by integrating velocity, let me use this in the problem and let's see how do we use it. So say for example, let's do one thing. Okay, yes. Okay, I'm going to take a function, guys. I'm going to take a function. Let's say velocity is maybe t cube. Example. What does this tell you? You put time as 0, velocity is 0. You put time as 1, velocity is 1. You put time as 2, velocity is 8. You put time as 4, velocity has gone to 16. So it tells you velocity is not changing uniformly. It is changing like crazy. Okay. So my point is, if velocity is given to you as a function, could be any function, and I want to know where the particle is. So first thing you should think, oh, velocity is the derivative of x. So integrating velocity, I will get x. So that's the first thought that should come to your mind. And just some time back, I told you x is integral velocity, right? And you will have some constant. So we'll start with this, guys. Let's start with this and observe now carefully. What is the velocity? Velocity is t cube. Everybody pay attention. T cube dt plus c. Okay, that c will always be there. All right, because if you are doing indefinite, you'll understand what indefinite is in a bit. Now, what is integration of t cube? Think about it. Integration of t cube, guys. Use x raised to n formula. So t cube, n is 3. So it will become t raised to 3 plus 1, which is 4, divided by 4 and plus, of course, c. So that is x. That is x. We got it. X is given. Okay, we got it. But the problem is I do not know what is c. So what do I do with it? Okay, let's think about it later on. But let me just substitute few values and see what happens. Let's substitute time as 1 and maybe time as, I don't know, maybe 2 seconds. And let's see what do we get. Let's just try it out. What's the harm? All right. Okay. So when I substitute time as 1 in this equation, what do I get? I will get the position at 1 second. At 1 second. So let's try this out. So it will become 1 raised to 4 by 4 plus c, which is nothing but 1/4 plus c. And when I substitute the value as 2, what do I get? I'll get 2 raised to 4 by 4 plus c is equal to nothing but 2 raised to 4, guys. Come on. 2 cube 8, 16, 16 by 4, 4 plus c. I hope you see that. Is everybody seeing that? Is everybody seeing that? Very good. Now, here is the thing. What if I subtract the 2? Yes, I subtract the 2. What if I do x2 minus x1? What will that be? Think about it. x2 minus x1. So it will be 4 plus c minus 1 by 4 k 1 by 4 plus c. Best part, c cancels. c just cancels. That's the best part. And this will become 4s are 16 minus 1 15. So it will become 15 by 4. And you know what this is? Do you know what this is? Just think the physical meaning of this. This is position at 2 seconds. This is position at 1 second. This is the change in the position from 1 second to 2 seconds. So actually speaking, it is delta x from 1 to 2 seconds. I have found this is nothing but displacement of the particle from 1 second to 2 seconds. That's what I got. That's what I got. It's 15 by 4 meters. Interesting. I got displacement. I didn't know position, but that's okay. Change in position is displacement. So that constant term anyways got cancelled. That's what I just saw. So just by knowing a function, I can find the displacement. Yes, if I know the velocity function, I can find the displacement. That's what I got. I hope you guys are seeing this. Now, you might be wondering, is this the way I will do integration every time? The answer is no. There is a better way of writing all this, and that is called as definite integration. Yes, there is a better way. Now, what is the meaning of definite integration and indefinite integration? Indefinite integration has this constant unknown term which has to be found out, and there are no things at the top and at the bottom of that integration. Those are called as the limits of integration. But the moment you put some things at the top and the bottom and this constant goes off, that is called as definite integration. Yes, now that's what I want to tell you. So when you use definite integration, when you know the value at one time and the other time and you are interested in the difference in the values. Yes, the difference in the values, that's when you will use definite integration. So let's see how do we use this. So remember this function. Remember this function, it was t raised to 4 by 4. Okay, and we started with v is equal to t cube. So how do we write this down as? So let's see how do we write this down as. If velocity was t cube, okay, x was integration of velocity with respect to time. This way of writing is called as indefinite way. Indefinite way. But in the definite way, I will never get the value of x. I will always get the value of delta x. Understand? That's one big difference. When I don't put anything over here and there is a constant, I get the value of x. But change in x, which was displacement, is what I get when I put few things over here. And what are those things? Well, it could be the values of time. Time as 1 second and then time as 2 seconds. Don't worry, you'll get it. Just hold on. I'll explain it to you. Velocity with respect to time. There is no constant over here. This is called as the definite way. Now, taking that previous example, if velocity was t cube, let's take this example and see how do we write it in the definite way. Remember, we substituted two values of time, t is equal to 1 second to t is equal to 2 seconds. The way you write it over here is integration of, observe this, integration of, same thing, velocity. What is that velocity? T cube dt, but put 1 second here and then put 2 seconds here. But this won't give you x. What will it give you? It will give you delta x. It will give you delta x. Just 1 second, I'll just reduce the contrast. I hope that is clear. I hope that is clear now. Now I just changed the brightness a little bit. I hope things are a little bit better. Okay, great. So what does this mean? This means just do your normal integration. Just do your normal integration. What is integration of t cube, guys? T raised to 4 by 4. Okay, t raised to 4 by 4. So just put t raised to 4 by 4, but do not put c. No, in definite there is no constant. Why? Because I know when I subtract two values, constant gets cancelled out. Yes, and just imagine it this way. I have to put the value of 2 and then I have to put the value of 1. Where? Over here in this t. So instead of t, you're going to put the value of 2 and then the value of 1 and subtract it. That's all. So this will be 2 raised to 4 by 4. So I substituted 2 and then substitute 1 raised to 4 by 4 and then subtract it. What is the answer? Think about it. I believe it should be 15 by 4 meters. So this is the easy way of writing it. Definite way. At two different values, you write the put in the values in that integral, subtract it, you get the change in the value of the integration. So this is just a notation. Please understand. It's not how. Whenever you put something here and something here, what happens is you will just do the normal integration without the constant and then put the upper value first and then you will put the lower value first and then subtract the function. You will get the answer. That's how it is. Okay, I hope this is clear. Now don't worry, we are going to solve some problems. You will get more hang of this. By the way, this is called as the upper limit and this is called as the lower limit. Okay, so this is called as the lower limit. Understand that? All right, very good. So keep paying attention, you will understand everything. It's like, you know, a lot of missing pieces of that puzzle, right? And you will see how nicely they will fit into each other. Let's try to understand this. First of all, integration of 4t cube dt. 2 is there below, 4 is there on the top. Is this definite or is this indefinite? First think about it. Is this definite or indefinite? Is there one constant? Modern world, just observe, you will understand everything. Yes. Thank you, Gopal. Okay. So is this definite or indefinite? Yes, this is definite. Very good. So what you should do is just do your normal integration. Now think, whose derivative is 4t cube, guys? Whose derivative is 4t cube? Just think, scratch your brains. Whose derivative is 4t cube? Think, whose derivative is 4t cube? Just think about it. Isn't it 2 raised to 4? Isn't it t raised to 4? Yes. So the answer for this should be t raised to 4. But remember, put brackets because there are limits. And do not put c because it's a definite integration problem. Okay. So put lower limit and put upper limit. What is the next step? Put 4 over here. So it will become 4 raised to 4 and then put 2 over here, which is 2 raised to 4 and then minus it. So whenever definite integration is asked, it means you have to substitute the upper value, then the lower value, then subtract the 2. But please do not do this. Please do not do this. What is that? Put time as 4 and then put time as 2, then subtract the 2 and then raise to 4. That is wrong. This is not correct. Please do not do that. You have to put the values and then subtract the functions themselves. Understand the difference. There's a subtle difference between the two. So that's the answer, guys. So 4 raised to 4 is basically 16 square, which is 256. 2 raised to 4, guys, is 16. So it should be 240, I believe. Very good. Very good, Jetty, Sonu, Deepak, Uncharted, Goodla, Laksh. Don't worry. Very good, very good. So let's go to the next problem, and that is definite integration. So whenever you have definite integration, you will have some number here, you will have some number here. They are called the limits. You will put those answers and then subtract that function. That is called as definite integration. Okay. So what is the physical significance? What is the physical significance of definite integration? Do not worry, we are coming to that. Look at this question. Come on, look at this question. The velocity versus time graph is given. Look at this. That graph is over here. Okay, each square over here is 1 unit. What is the distance traveled by the man in the 4 seconds, in the first 4 seconds? Come on, it's so easy, right? Yeah, I agree. It's so easy, but I gave it to you deliberately. Okay, 1 second. Are okay, so what is the answer, guys? Very good, 4 units. Excellent. So 1, 2, 3, 4, and this is 1, 2, 3, 4. Think about it carefully. Is it 4 or is it 16? Sudhiti, just concentrate. Don't worry. 2021, 2022, it doesn't matter. Just learn wherever you are getting knowledge. Okay. Yes, come on, think about it. Is it 16 or 4? What is the distance traveled by the man? So guys, distance is velocity multiplied by the time. What is the velocity? It is 4. What is the time? He has traveled for 4 seconds, so it is 16. But you know what? One more thing. This 4, right, is also the height of this rectangle, and this 4 is nothing but the base, this one over here. Height into base, what does it give you? Think about it. Height into base, it gives you the area. So this 16 is also the area under the velocity versus time graph. Yes, very good. It's also the area under the velocity time graph. Now, is it true that area under velocity time only for constant velocity will give you displacement? Is it true that only for constant velocity I'll get the area as the displacement? What if the velocity is variable? Something like this. Will the area under this curve also give me displacement? The answer is yes, it will always give. Now you might be like, oh sir, but the velocity is not constant, then what will you do? Here is my logic. Listen to my line carefully, think carefully what I mean. A variable velocity is constant velocity for brief instants of time, and for that each brief instant of time you can find the area which will give you small displacement, and then adding those small areas for each constant velocity for each small time will give you the total area, which will also be the total displacement. Think about it. Very good, Navmi Sonu. Yes, yes, very good, Krito. Yeah, I'll repeat. Each point is a constant velocity for a small time, and the area for that small point will give you small displacement, and adding all those areas will give me the total displacement even for a variable graph. Think about it. Very good. You guys understood this complicated statement. Yeah, you guys are real genius. Amazing. No wonder you are here. So how do we find the area? Should we take big rectangles? No, because then I'll be missing out on so many areas out there. I think to measure the area under the curve, I need to squeeze these rectangles to measure the total area. So I'll squeeze it, but still making it this small is not helpful. I think the time interval is too large. It's delta t. You can see there are some white spaces out there. So yes, I think you guys guessed it. You have to make it really small, such that delta t tends to 0. And when delta t tends to 0, what is it called? It is called dt. Yes, it is called dt. Now understand, guys, when I take, let me start over here. Let's say this point over here is t1. Let's say this point over here is t2. Then when this delta t tends to 0, what do I call this? I call this as dt. I hope you remember, when time interval or anything becomes tending to 0 but not 0, that is called as dt. That's the symbolic way of writing it. Then understand the area under the curve, right, is given by integration of, what is the y-axis? V. With respect to what? Time. And from where? T1 till where? T2. That will be the area of this part. Yes, that is the area of this part. Yes. So if you have been wondering what does definite integration give you, it is actually nothing but the area under the curve from one point to the other. And there is another interesting way of looking at it. Think about it. At any point, you take any rectangle, like for example, take this rectangle. What is the height of this rectangle? The height of this rectangle, guys, or basically the line, is V. Think about it. The height is V. And the width of this rectangle is dt. Okay? So height is V, width is dt. So area of that line, you know how much is that area of that line? Yeah, that one line, thin line, is V into dt. So area under curve from 1 to 2 will be the sum of all these areas, so many areas. So it is basically sum of all areas of the lines. So what is it? Summation V dt from T1 to T2, but there are many terms, infinite terms. So this complicated symbol is written down like this. Yes, this is how it is written down. So instead of writing summation from T1 to T2, and there are many terms, infinite terms, V dt, V dt, V dt, V dt, V dt, every V is different, every dt is different. So instead of writing it like that, we write it as integration. So Sudhanshu, all that you will be learning in maths. Yeah, okay. Very good. Because sigma is for finite terms. Understand? When the terms are countable. When the terms are not countable, when there are infinite terms, then the symbol for that is integration. Yes, that's how it is. I hope this is clear. Sudurti, if you don't make it small, then you wouldn't be calculating the actual area under the curve, because you'll be missing all those small gaps. Understand that. Only when you make it dt, you'll be measuring area under every point. Very good, very good. So let's go ahead. Let's solve this. So what is the integration of x square sine x dx? Come on guys, think about it. Well, the moment there is plus, use the same rule. Separate out the terms. Yes, separate out the terms. It is integral x square dx plus integral sine x dx. So what is the integration of x square? Use x raised to n formula. X raised to n formula, guys, come on, use it. It will be x cube by 3. N is 2, so n plus 1 by n plus 1. That's it. And do not forget integration of sine, guys. Yes, a lot of you got it. It is minus cos x. So minus cos x plus c. So that's the answer. So you can put that plus as minus out there. Very good, very good. So this works for both addition and subtraction, whatever you did in derivatives. All right. So let's see the rule. So if you have two functions, separate those functions and then you can add or subtract. This works not just for addition, this also works for subtraction. Remember that. So that's a simple rule to remember. Very good. Okay, let's go to the next rule. What if there is a constant outside? What if there is a constant outside? Well, if I want to find the integration of this, all you need to do is put that constant guy outside. That's it. Just like in derivatives. So minus 45 goes outside and x squares dx integration. So it will be minus 45. X squares integration, obviously we just saw, it is x cubed by 3. And do not forget plus c. So this will be nothing but minus 15 x cubed plus c. That's the answer. So the constant just comes outside. Very good. Okay. As simple as in derivatives. So the k comes outside. Remember that k comes outside. So Danshu, I think you should have that knowledge of derivatives, then you will find it very, very easy. Okay, next, cos 4x. Okay, 1 second. Cos 4x. Maybe let's complicate it a little bit more, guys. Yeah, let's complicate it a little bit more. Cos of 4x. 1 second. Plus 6 dx. Let's complicate it. Okay, so what is the answer for this? Well, here is the thing. Now this is very important. A lot of people forget this rule. This is called ax plus b rule for derivatives or integration. Whenever instead of x you have ax plus another constant, some constant into x plus some constant, then forget that. Just think what is the integration of cos. Just think what is the integration of cos. Integration of cos, guys, is plus sign. Correct. So it is sine. So just put sine of, put the same things back inside. Now, yeah, put that c also. Now, whatever constant gets multiplied with 4, just divide it with that. That's the answer. So the proof of all this will be done in maths. For now, you just need to learn the formulas. So if you have something x plus something, then just do the normal integration, and whatever is the multiplying factor, just put it down. I'll give you another example. That will make things very clear. Integration of 70 minus 2 raised to, I don't know, maybe like 3, okay, dt. So what will you do? Look at this thing. Yes, look at this thing, guys, as something raised to 3, something raised to 3. I hope you can see that. Something raised to 3. So what is something raised to 3's derivative? Integration. It is 70 minus 2, but instead of 3, what will you have? 4 divided by 4. Correct? Yes, this is like substitution method. So I'm making it as ax plus b rule. And last thing, what is the multiplying factor with the variable? 7. So divided by 7. That's it. That's the answer. So it will become 70 minus 2 whole raised to 4 divided by 28. That's the answer. Yeah, I hope you guys are getting it. So that 7 has to come down. Okay, so this always is true. Again, another example, integration of sine 3x dx. So integration of sine, what is integration of sine, guys? Minus cos. So minus cos, but put 3x as it is, plus c of course. Okay. And lastly, divided. What is the multiplying factor? 3. So just divide it by 3. That's it. That's the answer. Okay. So this is ax plus b rule. Very good. So yeah, there is a c over here as well. Okay. Very good. So now, that's the rule. F of ax plus b is integrate the function but bring that a downstairs. Okay, so that's what it is. Okay, so let's solve some more questions so that you get some hang out of it. So let's see who can do this. Integration of 1 by x minus x dx. Let's see who can do this. Come on, quickly guys, I'm waiting for it. Well, Sudhruti, you will not get the entire whatever I write PDF, only the slides you will get it as PDF, and in flash extracts you will get the pointers, the formulas and the definitions and the important properties, etc. All that you will get as flash extracts. Okay, let's see how many of you remember that 1 by x formula. Yes, Jay, I'm planning to take difficult questions once we complete with the mains. Yes, Erodo level, Croto level, sub questions I'm going to take. Don't worry. Yes, Abhinash, this is an English channel, so we are going to complete this syllabus only in English. Right. Jay Santosh, watch the video. There is one video where we have made when the syllabus will be complete, what should be the strategy, everything. And we are going to do it for mains, advanced, everything. So don't worry, we are going to complete all the syllabus. Okay, so yes, split it up. It is 1 by x dx minus x dx. Remember, 1 by x's integration was, yeah, a lot of people would have done this. I know this. They would have done this. X raised to minus 1 dx. and forget that. This will be just integration of x dx, which is x square by 2. Okay, you would have done this, some of you. -1 plus 1 divided by -1 plus 1. Now here is the problem. This will become x raised to 0 by 0. This is not correct. Do not use this. Do not use this. No, this is not correct. You cannot use x raised to n dx formula. Okay? Do not use it. Okay? So when n is -1, so here n should always be apart from anything apart from -1. Only then you can use it. Remember. So this is not correct. Only when n is -1. So what do you do? If n is equal to -1, that is 1 by x dx, the integration answer is ln x. So remember, this answer is ln x minus x square by 2. Yeah, so remember, that's only one special value. Okay, so let's take another problem. Let's do this. Integration of 7 minus 1 by x square dx. Come on, let's see how many of you can do this. Come on, come on, come on, guys. Let's do this. Come on, come on, come on, come on. Let's see how many of you can do this. Okay, so let's see this. Okay, so first separate it out. So 7 dx minus, write it in a beautiful form if you want to, or we can do it in the next step. So separate it out. Now this will be 7 taken out. Now you might be wondering, what am I integrating? Don't worry, I'll tell you. And this is integration of x raised to -2 dx. Well, this is simple. N is not -1, so I can use the x raised to n formula. So this will become x raised to -2 plus 1, which is -1 divided by -1. That's okay. But here you can think as if there is x raised to 0. Just think, because x raised to 0 is nothing but 1. Just think of it that way. It will make it look very simple. So what will it be? 0 plus 1. What is 0 plus 1? 1. So x raised to 1 divided by 0 plus 1. That's it. So that's the answer. So we can simplify it as 7x minus minus becomes plus, and that x comes downstairs, and of course plus c. Very good. Did you guys get it? How simple it is? So integration of dx is just x. Remember that. Integration of dx. Very good. Very good. So I'm pretty sure now you're getting a hang of it. Let's come to some physics related problems as well. So look at this. Look at this. We are going to do some really amazing questions now, which will open up your mind now. So pay attention. Okay. So particle is located at the origin initially. That's how I read it. Starts moving in the positive direction with some velocity which is variable. And what is the position after 10 seconds? That's what is asked. Now let's try to picturize this. Though you don't have to actually picturize in the exam or while solving, this is only for your explanation. That's all. Velocity is changing with time. And if one were to draw the graph of velocity with time, it would look like this, like a parabola, because this is a square term. And at every instant velocity is different. So I just cannot use displacement is velocity into time. That won't give me the answer. Second thing, I cannot use kinematic equations. Reason, acceleration is not constant. So the only option left, derivatives. So let's do that. Now, let's see what is asked. From velocity, we have to find position. Think, derivative of position is velocity. So integration of velocity is position. So integration, great. All right. So x is integration of velocity with respect to time. Now you might be wondering, should I do it the definite way or indefinite way? Okay, let's put a constant and see what happens. Let's see. Okay, so x is equal to integration. Velocity is t square. Guys, understand there are some students who are probably seeing integration for the first few times. So that's why I'm going a little bit slow. Plus c. Okay, so x is equal to, what is integration of t square? T cube. Okay, so t cube by 3. N plus 1 upon n plus 1. That's the formula I have used, plus c. Now, let's do one thing. Let's do one thing. What is given to me? See, it's given to me at time 0, x is 0. Use that fact over here. Yes, use that fact. At t0, x is 0. So using that fact, what will I get? 0 is equal to 0 plus c. Therefore, what will I get? C is equal to 0. Oh, then what do I get? If constant is 0, that's how you find the constant. Something will be given to you in the question. So you have to read between the lines. So x will be t cube by 3. That's it. That's the function. But that's not the end of it. The question is, what is the position at 10 seconds? So x at 10 seconds will be 10 cube by 3. So that is nothing but 1000 divided by 3 meters. That's the answer. Very good, very good, very good. Did you guys understand? Now let me tell you the graphical meaning of this. The graphical meaning is time starts from 0 and time goes till 10 seconds. If I were to calculate this area somehow, this area will also be 1000 by 3. Yes, this area will also be 1000 by 3. And we'll see it the other way now. Yes, we are going to see it by the area method. Very good. So guys, try to understand. I am trying to tell you how you can use indefinite way of integration to find the position if velocity is given. Now, you might be wondering, how do I choose between definite and indefinite? Well, Srikanth, I have mentioned about that in my previous session where all of us have spoken about which book to use. But if you are using a particular book, continue using that. But I prefer H.C. Verma, that's all. Okay, how to choose? In the previous way, we used indefinite method and we got the answer, correct? Now let's use definite method. So what to do in definite method? What is the change? Here is the change. See guys, x was integral v dt plus c. What is this way? This is definite way. In indefinite way, this won't come. Okay, plus c won't come. And the second change is you will have some t1 and t2, and instead of x, what will you have? Delta x. Yes, keep that in mind. You will have delta x. Keep that in mind. Now let's use this. So integration of what is t1? You have to think carefully, right? Nobody is going to tell you what t1 is. Let's see which all times I have. I have time 0 and I have time as 10 seconds. So let me use time as 0 and then the second time as 10. Do I have velocity? Yes, I have it as t square, and delta x is position at 10 seconds minus position at 0 seconds. So whatever you put here will come here. This is final or upper minus lower or previous or before. That's how it works. So this is after or later on or final, and this is initial or before. So higher minus lower, upper minus lower. That's how it works. So x at 10, that's what I need to find, minus x0, oh, that's given to me at time 0, x is 0, is equal to, remember t square's integration was t cube by 3, and because it's definite, you need to put these square brackets and put 0 and then 10, and then put 10 over here, and then put 0 over here, and then subtract the 2. That's it, that is 0. So it will again be 1000 by 3, but that is obviously x10. That's the answer. So which one should you use? Which one should you use, guys? Which one should you use? Same answer you'll get. It's your choice. Don't say this is better, that is better. Both are the same, guys. Yes, up to you. You like this? Go ahead. You like the previous one? Go ahead. No problem. But you should know both the ways. Remember that. You should know both the ways. Okay, great. Now that I see you guys are having fun, let's look at the last thing, and then you have mastered the mains level concept of integration, which is required for kinematics. Yes. So here is the thing. Acceleration graph. Remember, I just told you the derivative of velocity gives you acceleration, which is slope of velocity time graph. Now, if I know acceleration, how do I go back? You would have guessed it by now. Yes, the integration of acceleration with time, right, that will give you velocity. But if you do it indefinite way, you will get a constant. So this is indefinite way. But if you want to go the definite way, then you have another option, delta V is equal to integral a dt. Do not put c. It will be t1 to t2. That's the thing. That's the only difference. That's the only difference. Up to you, whichever way you want to go. Let's do a problem. That's the last problem for today, right? So I hope you guys are making notes while you are attending these sessions. Okay, so let's use this. So velocity is integration of a dt. That's what it is. So look at this. Acceleration is given as 6t raised to 5 minus 4t cube. And initial velocity is 30. Okay. What is the velocity as a function of time? So let's do this, guys. By the way, I'm really curious to know, let me know in the chat box. If I want to find velocity from acceleration, you integrate it, correct? If you want to find position from velocity, you integrate velocity. How would you find position from acceleration? How would you find position from acceleration? Think about it. No, Ali, think again. No, think again. Double integration. Matlab integrate once and then again integrate it. Very good, Rishabh, Mr. Boy. Yeah, see, if position is given, differentiating it gets velocity. Differentiating velocity gives me acceleration. So integrating acceleration gives me velocity. Integrating velocity gives me position. Yes. And I have put all of this in the session extracts, which is a summary. I have made beautiful charts for all of you. Yes, in the extracts, guys. So do not forget to check it out in the Telegram groups as well as the description link wherever it is. Okay. Yeah, very good. So let's solve this problem now. So acceleration is given. Let's find velocity. So velocity, guys, is integration, okay, with respect to time. Now let's go the definite way because I don't know, I liked it. So let's do it that way. So it should be t1 and there should be t2. Okay, I have to put limits, no constants. So let's do this. So lower limit, initial velocity, read the between the lines. Initial means time is 0. So 0. And find the velocity as a general function of time. So just put random t. Okay. A, what is A? Okay, this big thing, 6t raised to 5 minus 4t cube dt. Okay. Delta V is velocity at some random time. Look at that. Upper, bigger, higher, minus, lower, initial, previous, which is velocity at 0. That's it. That's how it will look like. So, what is the velocity initially? 30. Okay, so just put that is equal to. Separate it out. Actually, you can do it directly, guys. Whose differentiation is 60 raised to 5? Think about it. It is t raised to 6, right? It's t raised to 6. You can see that. And this is t raised to 4. You can see that directly. So you can see this is t raised to 6 minus t raised to 4. But put it in square brackets. Be careful. And put 0 and then put t. Now, what you should do, first put t over here. So, t raised to 6 minus t raised to 4. Done. Then put 0 in each of these things. So, 0 raised to 6 minus 0 raised to 4. Then subtract them. That's it. So, that is gone. So, this is t raised to 6 minus t raised to 4. But that is obviously Vt minus 30. So, therefore, Vt will be t raised to 6 plus minus t raised to 4 plus 30. That's the answer. That's the answer. Did you understand? Now, if somebody asked you what is position, integrate this. You will get x. That's it. So, this is velocity as a function of time. You got it. Isn't it simple, guys? I love this. So clear. Yes, Ali, it's very important. I'll be dealing with that in this week. So, Ali, we are going to do pulley related problems and that multiple pulley problems, constraint motion on Thursday. Tomorrow we are going to start with Newton's laws, FBD. There are some really amazing questions that I have planned for tomorrow. and pseudo forces, non-inertial frames on Friday, and the weekend with frictional force. Thank you guys very much, and do not forget to join the Telegram group in case you want to see the extracts, the summary, you want the drills, you want the assignments, you want all the notifications. Then please do not forget to join the Telegram group. We'll all be active over there. And if you have loved today's integration explanation, guys, come on, please go ahead and like it. Yeah, it's not going to cost you anything. Just go ahead and like. I would love to see all your likes and comments. Put comments. I will read every comment, and you all know I respond to all the comments put below YouTube. Okay, so go ahead and like and comment and share, guys. Come on, don't be so selfish. Spread the joy, spread it to everyone, and all the new timers out here, go ahead and subscribe right now. Yes, go ahead and subscribe. So Manju, the drill questions are very nice. Have a look at it. And like I said again and again, we're going to slowly scale up the level. And before you know, you won't even realize, oh sir, now we have started to do advanced problem. When did we start doing? You won't realize if you study with me. That's what I do. Right. Thank you, Brian. Thank you, Kishore. Thank you, Naomi. Very good. Very good. Bye-bye, guys. Take care. Take care. Take care. Bye-bye. See you. Have a safe stay at home. And keep coming, and do not forget to attend tomorrow's drill session. Bye bye. See you.